matrix related trainings today. So this is how you rename your Jupyter notebook. Okay, the untitled in the terminal spot, you just click on it and rename, say, and a page comes in, and starting up with matrix related. Then so I'm just going to rename it. You see that the name here changes, and this is how the dot pyd, the interactive Python, is going to be saved on my computer as a matrix related. Okay, to introduce you to a new concept today, which I call libraries. Okay, now Python has quite a lot of libraries. Libraries in the sense, other is a collection of programs. Okay, collection of functions, I should say. Functions എന്ന് പറഞ്ഞാൽ a small snippet of code which perform a particular task, which is already written and shared, uh, and is kind of built in, can be made built in into the system, is what we call a library. Okay, so Python has many libraries. Okay, there is something something called tensor എന്ന് പറയുന്ന ഒരു library, TensorFlow എന്നും കേട്ടിട്ടുണ്ടാവും. TensorFlow is kind of a Google library which helps a lot of machine learning. Okay, there is something called Keras. Okay, Keras is again another library set which helps a lot in machine learning and deep learning kind of things. Basic data sciences kind of സാധനങ്ങൾ സപ്പോർട്ട് ചെയ്യാനായിട്ടുള്ള വേറെ ഒരുപാട് libraries ഉണ്ട്, like maybe for example pandas. Okay, ഇതിന്റെ പേരുകളൊക്കെ നല്ല രസമാണ്, but still just get to know. You will get to know these, and a little bit of Google search will help you out. So TensorFlow, Keras, Pandas, Numpy, Scikit-learn, Matplotlib എന്നൊക്കെ പറഞ്ഞ ഒരുപാട് there are a lot of libraries. I'm just going to try to introduce one library today, and kind of help you, show you how libraries are generally invoked and how things can be done, and using that we'll do a little bit of matrix operation so that you understand that it's not really tough to go in Python. So what I'm going to introduce you today is something called Numpy. Okay, Numpy in the പറയുന്നത് is a library which helps on numericals. Okay, and I'll introduce you to another library which will help on linear algebra related things, so that you understand what and how things happen. So generally ആദ്യം ഒന്ന് introduce ചെയ്യാൻ, and then I'll show you a couple of examples, and then you will do your own program in detail. Now, import എന്ന് പറയുന്ന command is the hash include in C. It means that you're just invoking that particular library. Now I'm introducing you to Numpy. So what you have to do is you just import Numpy. Okay, so import Numpy in the പറയുന്നത്, you know that from this point on, in this particular Python environment, you will have Numpy kind of activated. So Numpy related കാര്യങ്ങൾ you can go ahead and solve it and do it. Okay, now Numpy എന്ന് പറയുന്നത് നകത്ത് നിൽക്കുന്ന functions നമുക്ക് invoke ചെയ്യണമെങ്കിൽ you will have to say that, say for example എനിക്ക് ഒരു array വേണം. Okay, so I'm just saying that I need an array. Let me call it a. So small a is equal to ഒരു array ആയിട്ട് എനിക്ക് invoke ചെയ്യണമെങ്കിൽ, ഒരു Numpy array എനിക്ക് invoke ചെയ്യണമെങ്കിൽ of say for example I want an array of all zeros. Okay, so zeros എന്ന് പറയുന്ന ഒരു command ഉപയോഗിച്ചാൽ I can get zeros of say 5. Okay, zeros of 5 എന്ന് പറഞ്ഞാൽ I can get an array which has all elements as zeros, and I will have 5 elements in it. പക്ഷെ അതൊരു Numpy array ആകണമെങ്കിൽ what I do is, zeros is a Numpy command. So Numpy command ആണെന്ന് മനസ്സിലാകാനായിട്ട് I say Numpy dot. Okay, so in this particular command here, a എന്ന് പറയുന്നത് is a variable, Numpy dot കാണിക്കുന്നത് Numpy എന്ന് പറയുന്ന ലൈബ്രറിക്കകത്തുള്ള ഒരു ഫംഗ്ഷൻ ആണ് റൺ ചെയ്യേണ്ടത്, zeros എന്ന് പറയുന്ന ഒരു ഫംഗ്ഷൻ ആണ് റൺ ചെയ്യേണ്ടത്, and zeros of 5 എന്ന് പറയുന്നത്, what zeros of 5 does is it actually just goes ahead and creates an array of zeros with values 0, and since I have a 5 here, I'm going to have 5 elements over there. Okay, so I go ahead and run this, Oh, that cancel. I forgot to put it. Okay, so print A will show me what A is. See, I get an array of all zeros. Okay. See this എനിക്ക് എപ്പോഴും numpy ഇങ്ങനെ ടൈപ്പ് ചെയ്തുകൊണ്ടിരിക്കാനായിട്ട് ഭയങ്കര ബുദ്ധിമുട്ടാണ് ബിക്കോസ് numpy കുറെ ലെറ്റേഴ്സ് ഉണ്ട് ആൻഡ് എല്ലാ ഫംഗ്ഷനും ടൈപ്പ് ചെയ്തതിന് മുമ്പ് ഞാൻ numpy dot എന്നിങ്ങനെ ടൈപ്പ് ചെയ്തുകൊണ്ടിരിക്കണം. So what we can do is we can make it a simple statement. I'm going to say that I want you to import numpy as numpy ആണെന്ന് അറിയാനായിട്ട് np എന്നൊരു പേരിടാം. Okay, so np എന്നുള്ള പേര് this np is not at all mandatory. എനിക്ക് വേണമെങ്കിൽ അവിടെ import numpy as shabari എന്ന് എഴുതാം. Okay, and if I write say import numpy as shabari, I'm going to say that shabari dot zeros, shabari dot ones എന്നൊക്കെ ടൈപ്പ് ചെയ്യേണ്ടി വരും. Okay, what I really need there is I want something very small and I want something that can be identified to numpy. Type എന്താണ് എന്നൊന്ന് നോക്കാം. So type of a എന്താണ് എന്ന് വേണമെങ്കിലും എനിക്ക് ചെക്ക് ചെയ്യാം. So that and I go ahead and see it works the same. So np numpy as np എന്ന് import ചെയ്താൽ ഇനി മുതൽ എനിക്ക് എവിടെയൊക്കെ ഈ പറയുന്ന പെർട്ടിക്കുലർ ഫംഗ്ഷൻ numpy ഫംഗ്ഷൻ റൺ ചെയ്യണം np ഡോട്ട് ആ ഫംഗ്ഷൻ നെയിം ടൈപ്പ് ചെയ്താൽ മതി. I can go ahead and I'll use that function. Okay, so there is another numpy function which can be done. So say for example I have a എന്ന് പറയുന്ന ഒരു array ആണ് ഇപ്പം എന്റെ കയ്യിലുള്ളത് അല്ലെ. എനിക്ക് a എന്ന് പറയുന്ന arrayയുടെ ഡീറ്റെയിൽസ് കൂടുതൽ കിട്ടണമെങ്കിൽ what I can do is a dot shape എന്നൊരു command. So shape എന്ന് പറഞ്ഞാൽ will show you what is particular function and what is the size of the size of this array എന്നുള്ളത് ആയിരിക്കും a dot shape എന്നാണ്. So if you really don't know what all functions are there within numpy, again shape എന്ന് പറയുന്നത് is a numpy function, you just need to go ahead and search for numpy. Okay, so Google എടുക്കുക numpy എന്ന് സെർച്ച് ചെയ്യുക. numpy.org എന്ന് പറയുന്ന ഒരു ഡീറ്റെയിൽഡ് വെബ്സൈറ്റ് തന്നെയുണ്ട്. Is this page visible right now? Hello? Tabs ഞാൻ മാറ്റുമ്പം does the tab come across?
Yes, sir.
Yeah, okay. So this is the website for numpy. This is the fundamental package for scientific computing within Python. So again, numpy ചിലപ്പം നിങ്ങളുടെ മെഷീനിൽ ഇൻസ്റ്റാൾഡ് ആയിരിക്കില്ല. In case you have not installed numpy as shown, or if you find import numpy എന്നുള്ള ലൈൻ റൺ ചെയ്യുമ്പോൾ okay, so ഇവിടെ റൺ ചെയ്യുമ്പോഴത്തേക്കും ഈ import numpy എന്ന് പറയുന്ന ലൈനിൽ if you are seeing some error over here, don't get frustrated. കൂടുതലൊന്നും ചെയ്യേണ്ട. You just have to go back to the video wherein I had shown you how to install things. Install Python and just use the command python -n pip install numpy. Okay, so just maybe jot it down over here. The best is python -n pip install numpy will do the trick. Okay, so the pip install whatever will do the trick of installing whatever libraries that you need. So if it is TensorFlow that you want to install, python and pip install TensorFlow will help you. Likewise keras, likewise pandas, likewise scikit learn and scikit image and all those things. You just need to use this function on your command prompt, and that will help you. So what numpy is about is numpy is more about n-dimensional arrays. It works well. It is open source. There is within numpy's website there is the interactive kind of interactive Python coder, so you can just enable here and type in and see how numpy functions. And the numpy code, there are other kind of visualizations, scikit image, and it's something that we're going to use today. OpenCV and pandas, these are all kind of supported libraries of numpy. So in astronomy and astrophysics, learning a little bit of Python is going to help you. And most image of black hole, if that interests you at all, was put together with SciPy, Matplotlib, and numpy. So that is kind of really interesting. And if you want to learn more and plot gravitation, and the theory of relativity and all those things, that is still a possibility to use NumPy and get all those things done. So don't worry, ഭയങ്കരമായ പാടുള്ള സാധനമൊന്നുമല്ല. It just takes a little bit of time to get ourselves fully accustomed to it. So don't worry about it. So I'll just show you a few commands and then let us go ahead and see how this works. So zeros in the function creates an array of zeros in the control. So likewise, if I want to go ahead and create an array of ones, so I can just type in, say, z is another variable, np dot ones, and I say like 10. So what is this going to give me? Okay, what might this be? Exactly, it is going to be an array of 10 ones in it. Now, there's one thing that you must notice here. NumPy by default considering the numbers in float item. Okay, 0 point and 1 point and NumPy is not taken things as integers, that are all taken in as floats. Okay, so this is no zeros and ones, and there is another command within NumPy itself which I call linspace. So linspace എന്ന് പറയുന്നത് command. So linspace, you can just go ahead and search for help linspace or do whatever. Again, linspace എന്ന് പറയുന്ന command. Okay, I'll just put in a hash. Linspace എന്ന് പറയുന്ന command is the same thing in MATLAB, in C, in Scilab. Okay, in a lot of other programs as well. So linspace is basically it takes as input a starting point. Okay, so say for example I start at 2, it takes as an endpoint, and say it takes etra elements of uniformly spaced, etra uniformly spaced elements ennullathu. Okay, so this is basically a function which I'll just run this and show you what this is. So see what happens. NumPy again ഒരു array ആണ് create ചെയ്തിട്ടുള്ളത്. I said the start. Okay, linspace start. So linspace start ചെയ്യുന്നത് is at 2. 2 can start ചെയ്യാൻ പറഞ്ഞു. എവിടെ വരെ പോകണം? I said 10 വരെ പോകണം. Okay, so start space, stop space. So this is the stop at 10, and എത്ര uniformly spaced elements വേണം അതിനകത്ത്. So I said 5. So I have 1, 2, 3, 4, 5 uniformly spaced elements inside this array. Okay, so എനിക്ക് 2 തൊട്ട് 10 വരെ uniform spaceൽ എനിക്ക് even numbers generate ചെയ്യാൻ പറ്റും. Say I want kind of 8 uniformly spaced elements between 2 and 10. See how the values change. So 2 ഉണ്ടായിരുന്നു because I have to start at 2, and 10 ഉണ്ടായിരുന്നു because I have to stop at 10, and in total I need 8 elements. So 1, 2, 3, 4, 5, 6, 7, 8 elements. So linspace എന്ന് പറയുന്നത് is kind of a function which can be used to create വളരെ ഫണ്ടമെന്റൽ ആയിട്ട് പറഞ്ഞാൽ accesses. So if you remember, നമ്മൾ കഴിഞ്ഞ പ്രാവശ്യം we started off with Laplace transforms and network theory. അത് നമ്മൾ ഭയങ്കര ഇമ്പോർട്ടന്റ് ആയിട്ടുള്ള കുറച്ച് ഫങ്ഷൻസിനെ കുറിച്ച് പറഞ്ഞിരുന്നു. ലൈക്ക് say for example the unit step, or even the ramp function, maybe a sinusoidal function. So maybe if you want to create a sinusoid, so let us do that example. Let us try to plot sine wave here on this guy here. So ഒരു sine wave കണ്ടാൽ എങ്ങനെ ഇരിക്കുന്നതെന്ന് ഓർമ്മയുണ്ടല്ലോ അല്ലേ? You must remember how a sine wave looks like. So say for example I say t, because x-axis there is time. So time varies another is as so I need an axis for that. So I'm taking t is linspace. I'm starting from 0. Okay, 0 will start either in here, maybe let me say 10 okay, and I'm saying I want it to be as smooth as ever. So I'm taking a huge number in the sense I want 0.000. So അത്രയും എനിക്ക് നന്നായിട്ട് ഉള്ള ക്ലോസർ ആയിട്ടുള്ള എലിമെന്റ്സ് കിട്ടണം എന്നുള്ളതുകൊണ്ട് I'll change this value and I'll show you what happens. So say for example I'm taking the sine of t. So sinusoid of t ആണ് എടുക്കേണ്ടത്. Again, NumPy very easily gives you sine എന്ന് പറയുന്ന function of t. Okay, Likewise, let me say I want to plot the cosine of p as well. So maybe I'll plot each of them separately in p dot sorry cos of the cos of p. Okay, so I have the sinusoidal values of each of these elements in an array. Okay, let me write the comments as well. So to create the base, maybe basing over here, let me say x-axis, okay, x-axis of the sinusoid. So this is the y-axis is sinusoidal values. Okay, this is just sine 2 pi f not put in the frequency component, that's not put in the magnitude component and all those things. So this is just a pure kind of sinusoid. And this is the okay y-axis. I think I'm plotting. So to plot, okay, I want to plot this thing. So I'm going to use plot another command. So let me just plot the sine underscore p. Okay. Now, do you find any issue here? Anyone? എന്തെങ്കിലും പ്രശ്നം തോന്നുന്നുണ്ടോ ഈ കോഡിനകത്ത് ഓടി നോക്കട്ടെ let me see is in space sinusoid. Okay, I know nobody is telling me anything, so let me go ahead and run this and let me see what happens. Thinking if there is a problem here and there is an error, and the error is plt dot plot. So ഈ ലൈനിലാണ് എറർ ഉള്ളത് എന്ന് ആഡോ വരച്ച് നമ്മുടെ ജൂപ്പിറ്റർ ചേച്ചി കാണിച്ചേക്കാണ്. Okay, ചേട്ടൻ കാണിച്ചേക്കാണ്. That there is a problem here. Now what is the problem? Plot main plt plot is not identified as a plt dot plot. So you now know that plot എന്ന് പറയുന്ന ഒരു command. So the np dot linspace ഞാൻ ഇവിടെ import ചെയ്തിരുന്നു, അതുകൊണ്ട് എനിക്ക് എററൊന്നും കാണിച്ചില്ല. ഞാൻ പക്ഷേ പ്ലോട്ടിന്റെ import ചെയ്തിട്ടില്ല. So what I have to do is I have to go ahead and import the library which is going to help plot things. So the library that's going to help plot is called matplotlib. Okay, so let me say I'm just going to import matplotlib. Now Tona, I want the Python plot function to be important. So I don't want the entire matplotlib to be important. I'm kind of plotting only the pyplot, and I'm going to plot it as plt. Because plot ചെയ്യാനായിട്ടുള്ളത് plt എന്നുള്ള ഒരു പേര് കൊടുക്കുന്നത് അത് പറ്റില്ല, easily identifiable ആണ്. Okay, so this line, തൽക്കാലം just understand that it is so you will gradually get to understand. Okay, gradually understanding on why I put plt. I already told you. So I'm going to run this right now and see, my sinusoid is a very good looking sinusoid. It takes a maximum value of 1.00 and a minimum value of 1 - 1.00 because there is no scaling factor here. So and the frequency is just 1. So etra elements are it goes ahead and takes a simple frequency. If I wanted, I could change the frequency by making the 2 pi omega part here, and maybe I could have a multiplied sine t with a scaled sine t. So maybe I can show you how that happens. So scaled sine is equal to, let me say, 5. Okay, so 5 times sine t, and I am going to plot the plt dot plot for scaled sine left. Let's see, ALED underscore sine. Let me try to plot that as well here on the same graph, and let me see how it works. Low, I get a sinusoid of the same frequency, but 5 times the amplitude. There's one parameter of a sinusoid. See, I'll say the same frequency because the zero crossing, see the zero crossing over here, zero even start to do, so 0 0 0 0 start to do. Okay, and മാക്സിമത്തിലേക്ക് പോയി ഇവൻ മാക്സിമം പോയി 1 വരെ എത്തി സോ സൈൻ ടി മാക്സിമം 1 ആയപ്പോഴത്തേക്കും 1 into 5 5 ആയി സോ സി 5 വരെ കയറി and then it came down back to 0 and it went to -1 even at the same time went to -5 and then it came back up and blah blah blah. So maybe let me see, let me kind of plot the cosine as well. See color മാറിയത് കണ്ടോ when I added multiple plots into the same plot, see how the color automatically changed. Let me plot the cos underscore t as well, so that you understand how a cosine looks like. And വീണ്ടും run ചെയ്യുകയാണ് the sine and cos and the scaled വന്നത് കാരണം it is not clearly visible. I'll do one thing, I'll just comment this line here and run again so that you see the sine and the cos. The sine and cos has come in. So sine 0 0 while sine 0 sorry cos 0 is 1. So 1 will start either it went to -1 and then came back to 1 and then went to -1 and it's going on. Okay. Now at this point I will just show you one very interesting thing. I'll just come this line as well and I will run it so that you see a cosine wave of Mata. Okay. Now this is a simple cosine wave. If you look at this, നിങ്ങൾ സോണിയുടെ വയോ സിമ്പിൾ കണ്ടിട്ടുണ്ടോ? വയോയുടെ ലോഗോയുടെ D and A is what you are seeing over here. അത് കഴിഞ്ഞിട്ട് there is a വയോ VAIO 10. So VA10 which shows V and A together is a cosine wave which shows analog data. 1 and 0 shows binary data. So Sony Vaio VAIO ആ പേര് shows analog to digital. You know, that's a very interesting kind of logo and design that Sony came up with in the last series of computing devices. This is a cosine wave. Simple, kind of tweak to remember what cosine waves is. Now, okay, so two important learnings here. Importing libraries. You just imported Numpy and you just imported matplotlib here, so that you generally understand how. I wanted you to understand how linspace works and how a sinusoid and a cosine is plotted. So you can go ahead and kind of so even you saw a matrix multiplication with a constant as well. Okay, sorry, an array. Okay, I wouldn't say matrix, an array. An array multiplication with a constant is what you just saw here. Because t in the പറയുന്നത് if you wanted to just see visualize t, you can just type in t and run. So t in the പറയുന്ന element is not fully displayed. It is an array. എന്നുള്ളത് കാണിച്ചു. Maybe I can say t dot shape is going to tell me the size of t. It is a one-dimensional array with so many elements in it. So 0 e to the power 0 it is purely 0. And it goes to 1 to the power e to the power -5 to the power 9 10 to the power it goes to 1. And then t and I took sinusoid so I get a uniform continuous wave over here. Maybe I change this to 10. Okay, if I change this to 10, let us see how things change. Okay, ഒട്ടും സ്മൂത്ത് അല്ലാത്ത ഒരു cosine wave because there is value at 0. ഇവിടുത്തെ വാല്യൂ കിട്ടി, 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 അത്രമേ ഉള്ളൂ. Okay, so the curve is not smooth. So as I increase the value here, the number of points, my curve gets smoother. Okay, so you can just tweak around with changing the values here and seeing the size. So 0 to 1 ana it is just a very small value. Etra elements it's just going to give you pretty much the same thing. So you can go ahead and take at least two cycles and overload and maybe you get more of your wave. So that is because the 2 pi omega t path is not over there. You can just go ahead and tweak around with this. This is an ideal value where you can get one full cycle. Okay, so play around with this and plot multiple different frequencies of sinusoids and see how things work and all those things. Okay, now I'm kind of planning to start off with a little bit more on lists and arrays. So I'll just show you. നമ്മൾ കഴിഞ്ഞ ദിവസം ലിസ്റ്റ് എങ്ങനെയാണ് എന്നൊക്കെ കണ്ടിരുന്നല്ലോ. So maybe I'm just going to take in a list here and show you how things work again. So maybe I'm going to take in a list of values which is again array list and whatever is a data type in Python. So what do I say? 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9. Okay, so I have a list of elements like this, and I want to see what my list is. So I'm going to print a list, and maybe I want to see the type. Okay, so print the little print it. Right. And I want to print the type of a list so that you know what kind of a list that is, because this is going to be Sada Python list. Okay, this is Sada Python list. Maybe I'm going to say that let me say Z. Okay, Z എന്ന് പറയുന്നതാണ്. I'm going to change it. I want to make it a numpy array. Okay, so in listener, if I want to make it a numpy array, I just use the function np.array in a bracket. I'm going to take in the list a underscore list. So this command, I'll show you. ഇപ്പം എന്താണ് സംഭവിക്കുന്നത് എന്ന് നോക്കിക്കോളൂ. Okay, I'm just going to print in C again, and I'm going to print in the type of C. Okay, now I want you to look at this small snippet here. I am, defining a list. I am printing the list and printing the type of this list. Okay, and I am using or invoking a numpy array function here. Okay, so invoking a numpy array function here. Okay, and I'll do just cut this, roll this into this, and then this there. So I'll show you what this is first, and then I'll show you what that is second. Okay, so this part is what I'm going to run first. I'm going to run this. Say A is going to be printed out as an array, and this is a list in Python. Okay, I'm now using this function, an empty function. I'm going to run this and see what happens. And this is right now considered a matrix. This is not a list anymore. This is considered a matrix, and that is what they call an n-dimensional array. So a numpy array, an n array, another array. So that this is a numpy array, or this is kind of a matrix. So np.array എന്ന് പറയുന്നത് ഒരു നോർമൽ ഡേറ്റ ടൈപ്പ് ലിസ്റ്റിനെ മാറ്റി ഒരു അറേ ആക്കുന്ന ഒരു മാത്തമാറ്റിക്കൽ അറേ ഫംഗ്ഷൻ ആക്കുന്ന ഒരു കൈൻഡ് ഓഫ് change ആണ്. Mathematical function. So this is a function that you might need as well. Okay, so you need to understand one more thing, that arrays are work ചെയ്യുമ്പോഴത്തേക്ക് or matrices are working. Either metrics are so maybe you can have two-dimensional metrics or three-dimensional matrices and all those things that can come in. So let me kind of show you another command. Let me say I have B underscore list. I'm taking in as a list itself, and then I will just change it. Now this time I wanted a list of lists. Okay, so I'm going to take in 9, 8, 7, 6, 5, 4, 3, 2, 1. It's one element. Okay, and I'm going to take this as another one. I'm going to take this as 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now this is some of the methods available, and let's use functions and see what this is. Because my variable has changed. Okay, and I'm going to use this function again. Okay. So this is B. So let us see what this guy is. Okay, now see, this is a list of this is one element, list of lists. This is the second element of that list. First element is a list itself. Second element is another list. So list of lists are generally Python counter. If I use the np array kind of function, see what happens now. This is a two-dimensional array with so many elements. So now this is a 2D matrix, or maybe 2 rows and 1, 2, 3, 4, 5, 6, 7 columns of the matrix. And now you are starting off with the matrix manipulations. Now, why do you really need matrices and all that? I'll just show you a couple of examples. I'm going to import something else right now so that you understand what this is. So I'm going to import from SK image എന്ന് പറയുന്ന SkyKit image എന്ന് പറയുന്ന ഒരു ലൈബ്രറി ഉണ്ട്. Okay, SkyKit image. That is SkyKit learn അകത്ത് വരുന്ന ഒരു പാർട്ടാണ് SkyKit image എന്ന് പറയുന്നത്. You will understand how it comes when you learn a little bit of ഇവിടെ NumPy-ക്കകത്ത് there is this guy image processing kind of things happening, and this then SkyPy signal processing kind of channel working in the tech. You will understand how this function comes in. So for the time, you just understand that there is SkyKit image, and then going to import import IO in the private function. I want the IO function to read something. So let me say that I'm going to read an email. So I want you to understand how matrix manipulations happen and how it is actually going to help you out in computing. So let me just say that I'm going to import into a variable photo. Okay, photo in the variable later. I am going to IO. So IO ക്കകത്തുള്ള IN read എന്ന് പറയുന്ന ഒരു function. Okay. Now again, as we said earlier, IN read എന്ന് പറയുന്നത് is image read. Okay, and the same function is the same function in math, lab, scilab, and all those things. Okay, and general scientific computing എല്ലാ പാക്കേജസിലും ഇമേജിനെ റീഡ് ചെയ്യാനായിട്ട് it is IN read എന്ന് പറയുന്ന function തന്നെ. And the function is you type in IN read and you type in the full location of where you have the image. Okay, so for the time being, environment work in the area I have the image. So I'm going to say Pala. In the primary image, because I have this image called the Pala. So I'm going to kind of import an image called the Pala. So Pala.jpg image, and read it in, and I'm going to show you what type this photo is. Okay. Okay, you can see what type this photo is. I mean, the type of this photo, and I will also do one thing. I will show you the size. Okay, print photo dot shape will show me what photo shape and so the size of the image is going to be shown. And let me see the image as well. The image in the comment. So for that, I use plot IM show. Okay, IM show photo. Again, over here, this function IM show is image show. In the function, same as in all other, SHO, W, and the show, W. Okay, so what this small snippet here does is it is going to read into the environment and image Pala. I'm going to show you what type this variable is. Okay, so ഒരു ഇമേജിനെ ആണ് ഞാൻ read ചെയ്യുന്നത്. .jpg ഇമേജ് ആണെന്നുള്ള ബോധം നമുക്കുണ്ടല്ലോ. So .jpg read ചെയ്യുന്ന ഫോട്ടോ എന്ന് പറയുന്ന വേരിയബിളിലേക്ക് ആ വേരിയബിളിന്റെ ടൈപ്പ് എന്താണെന്ന് എനിക്ക് പറഞ്ഞു തരണം, ആ വേരിയബിളിന്റെ സൈസ് എന്താണെന്ന് എനിക്കറിയണം. സോ ഐ വാണ്ട് the shape of this. So this is going to tell me the size of the variable photo. This guy is going to print the type. Okay, let us see and how the image looks like. Okay, I'm going to run this and this I don't know. Eureka! So what happens here? So what happens here? Photo pala.jpg read and it's going to tell me the type of this photo. Now, the type of this photo is a Numpy n-dimensional array. This is a Numpy array. Normally, this is a matrix. So as far as the computer is concerned, it's a photo. It's a matrix. And it is going to tell me what is the size of this matrix. Now 525 by 700 by 3 size ulla oru matrix aanu idu. Now what does this actually mean? It means that if you look closely over here, see 0 to 525 25 vere on the y-axis. Okay, normal, there are so many rows. Okay, there are 525 rows, and on the x-axis you have 700, starting from 0 to 600. Up to 700 ആയിരിക്കും നമുക്ക് വിശ്വസിക്കാൻ. 0 to 700 columns. Okay, so there are, this is a 525 row by 700 column matrix which has 3 dimensions. Now this 3 dimensions you will understand more when you learn more about image processing. For the time being, just understand that this is a color image. Now, since this is a color image, every element, okay, so you element over here, the small first element over here, the moon components of the red, blue, and green. Okay, so it is depending on the values of the red, blue, and green that you see this particular color here. Likewise, this small element over here has 3 values for corresponding to red, blue, and green, and that is what gives generally this pinkish color over here. Each of these colors is depending upon the value of the red, blue, and green. You will understand more on that when you learn a little bit of image processing in later semesters. So for the time being, just understand that this is 3 dimension. There is one array, or there is one matrix for red, there is one matrix for blue, and there is one matrix for green. And the size of the matrix is 525 by 700. Okay, so this is how you read in an image, and this is what an image is. Now, say for example, I'm going to manipulate. Okay, and let me just go ahead and manipulate this matrix. The photo of the matrix, let me just go ahead and manipulate this matrix. So I'm going to show you that let me just just for the fun of it, okay, plot.im show, I'm going to invert this matrix. Okay, so photo in the matrix in it, let me just invert. So colon -1. So -1 list in the -1 it goes to the end element and shows the end element first. I have told you that this is going to be an interview question as well. So -1 let me just go ahead and run this program and see what happens. See what happens. So what was 0 and 0 at this point? When I query and invert it, it went from this side to this side. Okay, so what happens here is, even column wise on the invertibility image, and see what happens as far as the image is concerned. The simple inversion of the matrix and the image in a color. But does that kind of change anything? Pixel values, no value has changed. It's just the position of the value that has changed. Let me show you another thing. So maybe then picture on the inverted marker. So plt.im show. I'm going to take photo. I'm going to take colon. Then I'm going to colon -1. Okay. Now what does this guy say on photo? So I'm going to run that. That's photo. Okay. If you see this and this, you see I have a vertical axis or mirror image. Now this changes your mirror image, row wise changing, inverts, column wise changing, makes a mirror image of your photo. So you see this roof, right side orange roof, orange roof left leg right leg, and Jesus was looking to the right, and Jesus is looking to the left. So this is up your mirror image. So that is how a little bit of matrix manipulations. Matrix manipulations happen or takes effect on images. Image or matrix, I'm just showing you how this thing works. Okay. So for example, let me show you. I want so okay, let me show you the photo itself. So I want the photo itself to come close, and I want to do something. Okay, so yeah, I have the original photo. Now, say for example, the matrix that you have 525 rows and 700 columns and all those things. Then എനിക്കൊരു ചെറിയ ഏരിയ മാത്രമായിട്ട് വേണമെങ്കിൽ Okay, I can go ahead and plot dot I am sure because directly എനിക്ക് കാണിക്കാൻ വേണ്ടിയിട്ടാണ് ഞാൻ ചെയ്തത്. ഓക്കെ, ഫോട്ടോയുടെ plot I am sure ഫോട്ടോയുടെ I want a small segment. Say for example, എനിക്ക് ഇതിനകത്ത് this is an okay, I want to cut off this small portion, and I'm particularly interested to learn more about this small part of this entire matrix. Enkil, I can just go ahead and look. Okay, so on my rowing this may be even 100 nikkuna, so 100 is somewhere over here, so maybe 100 but I would consider 150, and this is 0. So when it is 0 to 150 എടുക്കാൻ അല്ലെങ്കിൽ 50 to 150 എടുക്കാൻ ഞാൻ 40 40 to 125. Okay, so 40 to 125 of the row can pick either the row. Likewise, of the column, let me see, all of them are this is 300 and 400. Okay, let me say 300. Let me say 400. Okay, so 300, 400. മാത്രം എന്നെ എഴുതുന്ന പ്ലോട്ട് ചെയ്യാൻ പറഞ്ഞിട്ടായിട്ട് I see what happens. See, now the point is, anything go ahead, you know, use this command and experiment around. Let me say, I want this clock tower here. I want this clock. Okay, in the സമയം എത്രയാണ് എന്നുള്ളതിനെ കുറിച്ച് കൂടുതൽ മനസ്സിലാക്കാനായിട്ട് I want this clock. Now this clock എന്ന് പറയുന്നത് 300 സമയം here, 320 or 325 to 375 maybe. So let me say that I want 325 to 375 on the row, and in the column I want again 375 to 400, 375 or 370 to 400. Let me see. 370 വരെ പോകണ്ടായിരുന്നല്ലേ. Maybe I should take 370 later. I will take 330, 50 no, 40, 340, 400. Hi, at the clock. Now I can go ahead and see pixelate നിൽക്കുന്നുണ്ടോ? Okay, you see the small, good kind of thing. That's what you call a pixel in an image. And that is one value. Okay. Okay, so let me say, so 340 എന്ന് പറയുന്നത് വരെ പോകണ്ടായിരുന്നു, എനിക്ക് ഇവിടെ വരെ മതിയായിരുന്നു, 20 മതി, 360 എടുക്കാം, 360 ഉണ്ടോ ബ്ലോക്കിനെ കുറച്ചുകൂടെ ശരിയാക്കി എടുത്തു. ഞാൻ ഇവിടെ 400 വരെ പോകണ്ടായിരുന്നു, എനിക്ക് 30 360 390. എന്റെ ക്ലോക്കിനെ മാത്രം തീർത്തു. 325 വേണമെങ്കിൽ നിങ്ങൾക്ക് കുറച്ചുകൂടെ ക്ലിയർ ആക്കാം. ഐ ക്യാൻ മേക്ക് ഇറ്റ് 335 ഒന്ന് ശരിയാക്കി. ഇവിടെ എനിക്കൊരു 35 70 അല്ലേ. I got my clock. Okay, so I have segmented my clock from that image, and if into സമയം നോക്കാം, I know that this image was captured at 10:30 a.m. ആണോ p.m. ആണോ? What do you say? ആരെങ്കിലും ആൻസർ പറയൂ. Is this 10:30 a.m. or 10:30 p.m.? Alvin Sebastian, അതുണ്ടോ?
ഹലോ,
ഇത് 10:30 a.m. ആണോ 10:30 p.m. ആണോ?
ആയിരിക്കും, പകലല്ലേ?
പകലല്ലേ, എം ആയിരിക്കും, കാരണം ചുറ്റും നമ്മൾ നീല വെളിച്ചമൊക്കെ കണ്ടായിരുന്നു അല്ലേ. Exactly, so this must be 10:30 a.m. So my point here is, my fundamental point here is, ഇമേജ് പ്രോസസ്സിംഗ് എന്നും പറഞ്ഞ് നിങ്ങൾ ഫോട്ടോഷോപ്പിൽ പഠിക്കുന്നതും നിങ്ങൾ ഫോട്ടോഷോപ്പ് ചെയ്യുന്നതും നിങ്ങൾ മൂവീസിൽ കാണുന്ന യുനോ ഇമേജ് എൻഹാൻസ്മെന്റ്, മറ്റേ ട്രാഫിക് ക്യാമറയ്ക്കകത്തുള്ള കാറിന്റെ നമ്പർ പ്ലേറ്റ് എക്സ്ട്രാക്ട് ചെയ്യുന്നതും are all simple matrix manipulations. So understanding how matrices works on computers is very important. Okay, you saw what happened, right? The image and the size and noki. So the process I did is the flowchart. What I did here was I checked the size of the image and I zeroed in into the particular area of my interest. And our area of interest in a matram when I went ahead and glowed it up, I segmented it, I took it up. So maybe എനിക്ക് ഈ ഒരു particular ഒരു pixel value മാത്രമായിട്ട് കാണണമെങ്കിൽ you know that this is values, pixel values, and it is just numbers out there. Okay, now this is just one example. Maybe I can also show you that if I want to compress the image. Okay, I can also do that. I can just say I am show. I can say photo, and I can use the command that I want to reduce the rows to, and I want to reduce the entire columns into. Okay, and I'm going to show you that from top. See, the photo which was 525 is right now 200 and something, and what was 700 is right now 350 something. So this is image compression. Okay, I have reduced the size of the image by 2. So image compression എന്ന് പറയുന്ന compression ആണ് ഞാൻ ഈ ഒരു function കൊണ്ട് achieve ചെയ്തിട്ടുണ്ട് by reducing the number of rows and columns by 2. Have I lost anything in the image? Have I lost anything in the image? Visual inspection, I have not lost much. Okay, upon visual inspection, I might not have lost much, but using matrices like mean square and a few other things, then maybe something is lost. Okay, so this is about generally about a little bit of kind of understanding, and maybe there is something that I can as well do. Okay, a little bit of metrics in other. Maybe I can use a little bit of boolean as well. Say for example, I have a function. The function empty array under the top. Okay, I have an empty array which is which values of 1, 2, 3, 4, 5, 6. Okay, and say for example, okay, let us see what it is. So it is an array of 1, 2, 3, 4, 5, 6. If I want to see where all this guy takes a value of greater than 3. This is the average A ana engine. See what this does. The NP array ആയത് കാരണം if I just type in z greater than 3, see what happens. ഈ arrayക്കകത്ത് ഓരോ condition boolean ആയിട്ട്. So is 1 greater than 3 is false. 2 greater than 3 is false. 3 greater than 3 is false. 4 greater than 3 is true. 5 greater than 3 is true. 6 greater than 3 is true. Likewise, I can do the inverse as well. Okay. Less than 3. See what happens? True, true, false, 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 false. Okay. So I can kind of mask values within an array as well. So say for example, I go back to the image and image and mask and go on. So photo underscore mask is equal to I'm saying that np. So again numpy I'm saying wherever the photo takes a value greater than 100, okay, photo. Now this is where np wherever the photo value 100 മുകളിലാണോ അതിനെ 255 ആക്കും. Okay, the significance of 255 and 0 again you will understand when you learn a little bit of image processing. So 255 0 തൽക്കാലം ഒന്ന് മനസ്സിലാക്കി വെച്ചോളൂ. These are two extreme values that a pixel can take values. Okay, a pixel intensity can take values 255 and 0 ആണ്. തൽക്കാലം അത്രയും മനസ്സിലാക്കി വെച്ചു. I'll come to that later. So just for the time being, understand that I'm going to show you a mask. So let's go mask. Okay, let us see what happens. See, because of the intensity value 100 മുകളിലുള്ള എല്ലാത്തിനും കയറി 255 മാറ്റും. 255 എന്ന് പറഞ്ഞാൽ it shows pure white. Okay, so 255 shows pure white. 0 shows pure black. So any value greater than 100 make it 255, show it as pure white. Any value less than 0 less than any value greater than 100 make it 255, any value less than 100 make it 0 എന്നാണ് പറഞ്ഞിരിക്കുന്നത്. അപ്പം ഇതിന്റെ ഈ ചെറിയ ഗ്രീനും ബ്ലൂവും ഒക്കെ എന്തായിരിക്കും? What do you say? Greater than 100 to 55, less than 100, 0. What will be with the blue, with the blue, with the green, and with the slight yellow colors? I'll let you know. Okay, maybe we can try to find out. So this is how you go ahead and mask, in an image. So these are all possibilities that you can do, and image ഒരു മെട്രിക്സ് ആണ് എന്നുള്ളത് ഒന്ന് മനസ്സിലാക്കാനും മെട്രിക്സ് മാനിപ്പുലേഷൻസ് ആർ ഇമ്പോർട്ടൻറ്റ് എന്നുള്ളത് ഒന്ന് മനസ്സിലാക്കാനായിട്ടും ഉള്ള ഒരു ചെറിയ എക്സസൈസ് ആയിരുന്നു. So say for example that you have a couple of arrays. You can go ahead and use a simple program, simple functions to say, let me define an array. So A in the array, I'm going to define it as np dot array. Let me take the value of 1, 2, 3, 4. Yes, I'm going to take the 4 matrix, and I'm going to take a B array is equal to np dot array, and I'm going to define this guy as 4 and like 5, 6, 7, 8. Okay, so I have two arrays. I can go ahead and perform the addition. So addition is equal to a underscore array plus b underscore array, and we have the plotted a underscore array and b underscore array and addition. Okay, now let me just run this and see. Okay, I've not print just to show. So friends and friends and everything in them. See what happens. I get 1, 2, 3, 4, 5, 6, 7, 8, and simple addition. What does it do? It adds element by element. So 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 10. Okay, so addition performs, kind of a simple addition. Maybe I can add just with the scalar. So a underscore array plus 85 is, and when I run this, 1 plus 85 is 86, 2 plus 85 is 87. I can add with a scalar. I can kind of multiply these two arrays. So array star b underscore array, multiplication. So element by element multiplication is what happens with star. And then maybe if I want a kind of a dot product, what I can do is I want to make this a scalar. Okay, so vectors okay, which is so if I want the dot product, what I do is dot. I put a period and a dot b array is going to give me the dot product, which is 70. So this into this plus this into this plus this into this is what happens. And there is another function which does the same thing. Okay? At the rate b array is going to give me the same function. Okay, so dot product I can either put a period and a dot and a dot and a dot and a dot and a dot, and then I can just put at the rate and the symbol. So that is a possibility. I can even take the transpose. Okay, so a underscore array dot capital T. It gives me the transpose of the array onto the table, because this is column. I'll do one thing. I'll just plot the transpose of the photo that we did. So photo, I am show bracket photo. It's a column. So I will say and dot P. I will just show the transpose effect of that image, and see the transpose came in as portrait in a landscape of it, and so landscape in a portrait of the. So that is a possibility. Okay, so There are other functions as well. So maybe this is one method of manipulating arrays. And there's another method of manipulating arrays. There is another Python library, which again, with the library into I'm just kind of introducing you to, which is scientific Python. So SciPy. Okay, so from SciPy, I can go ahead and import linear algebra. So linear algebraic വേണ്ടിയിട്ടുള്ള ഫങ്ഷൻസിനെ ഇമ്പോർട്ട് ചെയ്യാനായിട്ട് പറയാണ് ഫ്രം സയന്റിഫിക് പൈത്തൺ. ആൻഡ് ലീനിയർ ആൾജിബ്ര എന്നുള്ളത് പെട്ടെന്ന് പറയാനായിട്ട് what we usually type in what coders usually use is LG. Okay, so linear algebra LG. So you can go ahead and kind of import the linear algebra function. If you have linear algebra functions, then things are slightly more easy in terms that there is one particular function that you can do. Say for example, I have an array. Let me go ahead and define a new array here. So I'm going to define a new empty array, which is a matrix. Sorry, a matrix, and I'm going to make that matrix list of 1, comma 3. Okay, so let me try to make this a 3 by 3 matrix. I'm going to click on, and then going to open up another, and then make it 4, 5, 6, close, open 7, 8, 9. Okay, this is a small empty matrix. So let me go ahead and print A so that you understand what this is. Okay, now this is a one row, second row, and third row, 3 by 3 matrix. 1, 2, 3, 4, 5, 6, 7, 9 is a 3 by 3 matrix. Let me go ahead and take another matrix. So B is equal to, I'm going to take another 2 by 3 matrix. Okay. So matrices lecture manipulations and data. Another matrix. Which is 10, 20, 40, 40, 50, 60, 70, 80, and 90. And and so I have an array which is 10, 20, 30, 40, 50. So I have two, what do you call 3 by 3 matrices here. And I can with linear algebra in, I can just kind of sum AB. I can just go ahead and put A plus B, and that's going to be the sum. Sum AB. It's going to show me, element by element addition of the products. So I can go ahead and, maybe say difference is equal to A minus B, and let us say difference of 1 to negative values are all going to be shown. I can do the dot product. I can get the transpose. Okay, I'll show you the transpose here. And transpose is equal to A dot T, and maybe if I want the determinant, okay, this is transpose, and transpose will show me the transpose. So 1, 2, 3, 4, 5, 6, 7, 8, 9, add another. Okay, I'm sure print A and print A. So and I'll print transpose. So to see that what happens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, add another. 1, 2, 3, column I, 4, 5, 6, and 7, 8, 9, column I. Okay, so what was the row? So it's now the column. That is what transpose was. So you see that generally works. Maybe I can say determinant of B. I can this comes from the linear algebra. So LG dot det of B is going to be the determinant of B. So ഞാൻ ഇവിടെ det B എന്ന് കയറി കൊടുക്കുകയാണ്. ഡിറ്റർമിനന്റിന് det എന്ന് പറഞ്ഞാൽ എനിക്ക് വേരിയബിൾ നെയിം കൊടുക്കാൻ പാടില്ല, because that is a function. Okay, so determinant എന്നുള്ളതാണ് you can go ahead and use the entire thing. So determinant of that particular guy is 0 is what you shown. maybe likewise you can say, print if you want the inverse. You can just invoke ng dot inverse of b. So that will show you the inverse of b. So b the inverse one by b, that's going to be computed. So LG, the linear algebra എന്ന് പറയുന്ന, so Skytip നകത്ത് linear algebra എന്ന് പറയുന്ന kind of Python library gives you all these things which can be done. And most important, okay, most important, what this guy does is it gives you values, eigenvalues, and eigenvectors. Function to go ahead and compute eigenvalues and eigenvectors matrices. So if you remember properly, you need a square matrix to go ahead and compute the eigenvalue and the eigenvector. Eigenvalue and eigenvector as far as scientific computing is very very important because image നമ്മൾ കുറച്ച് properties ഒക്കെ ചെയ്ത് ഇങ്ങനെ അങ്ങോട്ടും ഇങ്ങോട്ടൊക്കെ ചെക്ക് ചെയ്തായിരുന്നല്ലോ. A few things was done. We are kind of changing position and all those things. So when you kind of change these things, eigenvalue and eigenvectors are those parts that have something's happening on it. Something does not change. Something does change. As far as vectors are concerned, the eigenvalue and eigenvectors has a lot of physical importance. I want you to go ahead and do a small exercise. I want you to uh, type in into Python a 5 by 5 matrix. Okay, type in two matrices 5 by 5. Perform all arithmetic functions on it: addition, subtraction, division, multiplication, and all those things. And also plot the eigenvalues of the matrices. Okay, so any two 5 by 5 matrices, perform all mathematical computation, arithmetic operations on it, and plot the eigenvalues of the matrix. Okay, lg dot eigen of b എന്ന് പറയുന്നത് gives you the eigenvalues and eigenvectors. So values എന്ന് പറയുന്ന ഒരു വേരിയബിളിനകത്തേക്ക് eigenvalues വരും, vectors എന്ന് പറയുന്ന ഒരു വേരിയബിളിനകത്തേക്ക് eigenvectorsനെ എടുക്കും. And I've just showed you to go ahead and print the eigenvalues. Eigenvalues മാത്രമായിട്ട് ഒന്ന് print ചെയ്ത് കാണിക്കാം so that you understand what the eigenvalues are. And പിന്നീട് you can go ahead and print the eigenvectors so that you can see what the eigenvectors are. So these are the eigenvalues. You see that the eigenvalues are complex in nature, complex numbers ആണ്, and these are the eigenvectors. So eigenvector number of b എന്ന് പറയുന്നത് is takes negative values and positive values. So each of these elements ഇതിനകത്ത് ഈ points ആണ് the eigenvectors. At times certain values might not have eigenvectors, certain values might have eigenvectors. So here everybody has. So go ahead, try this for different values. ABCD motor 1 2 3 4 motor. Enter different values for the matrices and check the different eigenvalues and eigenvectors and see how they come in.